Question number 36, thermodynamics and thermochemistry. Given that heat of neutralization of strong acid strong base is minus 57.1 kilojoules, so heat produced when 0.25 mole of HCl is neutralized with 0.25 mole of NaOH. It's a very simple question. Very simple question. Please understand this. 1 mole of neutralization gives minus 57.1 kilojoules. So therefore, 0.25 moles will give minus 57.1 into 0.25 moles. It's something like cross multiplying this x, you find out x, what is x? Multiply this, you're going to get 14.2 approximately, minus 14.2 kilojoules. That's option A. Gas phase, for the gas phase reaction, PCl5 giving PCl3 plus Cl2, which of the following conditions are correct? So whenever we discuss this kind of reaction, okay, this reaction is an example of decomposition reaction, and we know that for decomposition reactions, these reactions are decomposition reactions. This is a decomposition reactions, and they are endothermic. Decomposition reactions are endothermic, right? It's very important just to understand. Therefore, for this reaction, delta H will be positive. Coming to the entropy factor, so entropy factor is number of product gases 2 minus number of reactant gases 1 is equal to 1, which means it is positive. Therefore, delta H is positive and delta S is positive. Therefore, option B is correct. Kindly note it down. So the most important point here to discuss is decomposition reactions or endothermic reactions. Kindly note it down, children. All decomposition reactions are endothermic reactions. It's very, very important for you to understand this point of time. So decomposition reactions are all endothermic reactions. Very important point to note it down. Unless and until the heat energy is supplied to the system, the decomposition will not happen to break the bonds. Therefore, decomposition reactions are all endothermic reactions, right? Copy down, please. Yes, Anish, we'll shortly start S block, don't worry. Question number 38. Identify the correct statement regarding to entropy. At absolute zero temperature, entropy of a perfectly crystalline substance is taken as zero. This is called the zeroth law of thermodynamics. Which is correct. All other statements are wrong. Next slide. Choose the reaction which has negative delta S value. For this equation, delta S is gas 1 mole, gas 1 mole, 2 moles. So positive. For this, gas 2 moles, gas 1 mole, positive. For this, gas 1 mole, reactant product to 1 mole, reactant 2 moles, delta S negative. Correct. Option D, delta S positive. Therefore, option C is correct. Can you note it down? Next slide. Last question for this thermodynamics. So, for a particular reversible reaction, temperature T, delta H, and delta S were found to be bound both positive. If TE is a temperature in equilibrium, the reaction is spontaneous. So, most important thing, children. At equilibrium, delta G will be equal to 0. Therefore, delta H minus T into delta S is equal to 0. That means delta H is equal to T into delta S. That means TE equal to delta H by delta S. For a spontaneous reaction, delta H minus T delta S less than 0, because delta G is less than 0, which means delta H less than T delta S, which means T would be greater than delta H by delta S, which means T is less than T. T is less than T, or T will be greater than T. That's option B is correct. Next slide. So that's what is thermodynamics and thermochemistry, children. Please learn the formulas, whatever we discussed in thermodynamics and thermochemistry. Let us go to S block elements. S block elements is a really highlight chapter for learning the periodic properties, and definitely you would definitely learn a lot of things in the periodic properties and some of the reactions of S block elements. Okay. Yes. Question number 1. Order of solubility of lithium halides in non-polar solvents. Order of solubility C, very important. Let us understand something called Fajans rules. Non-polar solvents, they are nothing but organic solvents. Non-polar solvents, example, carbon tetrachloride, etc., where covalent compounds have the high degree of solubility. Accepted? High degree of solubility. Whether lithium fluoride is covalent or lithium iodide is covalent. Answer is lithium iodide is covalent. Please go through Fajans rules. Please go through Fajans rules. You will learn that lithium iodide is more covalent than lithium fluoride. Therefore, option B is correct. Please open up your chemical bonding manual and learn why lithium iodide is more covalent. Alkali metal that form normal oxides, peroxides, as well as superoxides, potassium and rubidium. They can form normal oxides, peroxides, as well as superoxides. Option B is correct. Kindly note it down. Next slide. Which of the following statements are not correct? Is not correct. Lithium chloride is predominantly covalent. We cannot say that it is predominantly covalent. Lithium nitrate is stable compound. No, it gives lithium and nitrogen. Lithium carbonate decomposes giving CO2. This is also correct statement. Lithium bicarbonate is known in the solid state. No, lithium carbonate is known only in the solution state. Therefore, option D is a false statement. All others are true statements. Next slide. The correct order of stability of superoxides. Please understand one thing, children, very clearly. Lithium, sodium, potassium, rubidium, cesium, francium. Stability of superoxides increases down the group. Stability of superoxides increases down the group. That means cesium superoxide is more stable than rubidium superoxide. Rubidium superoxide is more stable than potassium superoxide. Therefore, option C is correct. Please note it down. Going to the next slide. Select the correct statement. Solubility of alkali hydroxides are in the order cesium hydroxide, rubidium, potassium, sodium, lithium. Let us have a highlight on this. Children, this is cesium, this is hydroxide. Can a bond form between elephant and ant? See, investigate my question correctly. Can a bond form between elephant and ant? Bond cannot form between elephant and ant. Means highest size and lowest, smallest hydroxide ion size. Therefore, what is the meaning of this? This means that the bond is weak. That means it can break easily. That means hydroxide ion can come easily. Therefore, cesium hydroxide is highly basic and lithium hydroxide is least basic. Therefore, option A is correct. Coming to option B, solubility of alkali carbonates is in the order. So please understand one thing very clearly. Carbonate is a bigger size ion. Therefore, cesium carbonate is highly stable and lithium carbonate is least stable, and lithium carbonate does not exist in the aqueous solution. Therefore, the order will be reversed. Therefore, option B is wrong. Therefore, option both are correct is not correct. None of the above is correct is also wrong. Therefore, option A is correct. Kindly note it down. It's very important. Lakshmi, you want me to repeat why option B is wrong in the previous slide? See, lithium carbonate is not so stable because carbonate is a bigger ion, right? Carbonate is a bigger ion. It can be stable only with cesium carbonate. Cesium carbonate is highly stable. Solubility means cesium carbonate can be easily converted to carbonate ion cesium ion, whereas lithium carbonate is stable. Therefore, the order should be reverse, but it is given a decreasing order like this. Therefore, alkali metal carbonate should have the reverse order. Alkali metal carbonates and sulfate should be having the reverse order, but it's given the forward order. Therefore, it is not correct. Coming to the next statement, next slide. Correct order of solubility of fluorides of alkali metals is, the most important fact here is barium fluoride. When you talk about solubility in water, that is the situation here. See, barium is a bigger cation, fluoride is a small anion. Therefore, this is a covalent compound. Understand this according to Fajan's rules. So, barium fluoride is least soluble in water, whereas beryllium fluoride is highly soluble in water. Therefore, option A is correct. There is a doubt from a child. I'll address it. Vaishnavi Venkatesan. Covalent bond have high degree of solubility. Vaishnavi Venkatesan. Covalent bond can have high degree of solubility provided it is soluble in organic solvent. When generally it is said that solubility of fluorides, it is meaning that solubility of these compounds in aqueous solution. Unless and until the solvent is mentioned, we have to consider that solubility is in aqueous solution. Vaishnavi, did you understand? Therefore, solubility of these compounds in aqueous solutions follow this order. Option A is correct. It's good that a lot of doubts are coming inside. Please clarify, because the periodic properties are very important in solving. See, 50% of the questions are, see, when you take inorganic chemistry, let me give a clarification for you. Please follow these instructions. Whenever you take inorganic chemistry questions, 50% of the questions will come in reactions, and remaining 50% of the questions are going to come from periodic properties and chemical bonding. When I say chemical bonding, you should know what is the bond order of that particular compound, hybridization of the particular central metal atom, covalency of the compound. All these things comes inside. This chemical bonding and moreover dipole moment is also coming into questions. So these kind of questions, if you please concentrate, definitely you will come to know. One more doubt from a child. Ria Mali, how is electronegativity and solubility related? Ria, here electronegativity will not come into play because all the compounds are fluoride compounds. The metal is electropositive and the halogen is electronegative. If this turns out to be an ionic compound, it is highly soluble in water. Not only water, highly soluble in polar solvents. If this is covalent, then it is soluble in inorganic solvents. Sorry, it is soluble in organic solvents. Understand? If it is covalent, this, for example, let me take sodium iodide. Is it soluble in water or it is more soluble in ether? The answer is this is more soluble in ether because it is a covalent compound. So based on the Fajans rules, we decide whether the compound is covalent or ionic. So depending upon that, we decide whether it is soluble in organic solvent or polar solvent, right? Ria, you have typed a certain textbook. It is given that fluoride's negativity decreases down the group. What is the meaning of fluoride's negativity? Fluoride's electronegativity, huh? Depends upon the cation, Ria. Okay, yes, yeah. Beryllium shows diagonal relationship with aluminium. Which one of the following properties is not shown by both? See, very simple. Beryllium, please understand, beryllium and aluminium has similar size. Okay, that means both are amphoteric. That is proved because both react with acids and bases. Both are methanides. What is the meaning of this? If you dissolve in water, both gives methane. Both carbides gives methane. That is the meaning of methanides. Both have maximum covalency. Wrong statement. Why? Beryllium does not have vacant d orbital, whereas aluminium has vacant 3d orbital. Therefore, covalency cannot remain the same. For example, beryllium can have maximum covalency of 4. Existence sodium tetrahydroxy berylate. Sodium tetrahydroxy berylate can exist. Maximum covalency of beryllium is 4. Aluminium, Al, H2O, 6 times 3 plus can exist. Here, maximum covalency of aluminium is 6. Therefore, this does not match. Therefore, option C is incorrect. Both occurs together as beryl is correct. Anaga, option D is correct because both can form beryl compounds. Okay, yeah. Next slide. Which of the following pairs can be distinguished by the action of heat? Question number 8. Which of the following can be distinguished by the action of heat? When I discuss the action of heat, it's very important that we need to write the reactions. See, very simple. Sodium carbonate, if you heat, nothing will happen. All of you know, calcium carbonate, if you heat beyond 1100 Kelvin, you will get calcium oxide and CO2. Right? If you pass carbon dioxide in lime water, it turns milky. So you can distinguish these two. Therefore, option 1 can be distinguished by the action of heat. Option 2, magnesium chloride hexahydrate, if you heat, what will happen is you will get MgOHCl, magnesium chlorohydroxide, along with HCl and 5 water molecules. If you heat calcium chloride, you will get CaCl2 plus 6H2O. That's it. If you introduce this HCl in ammonia solution, you will get dense white fumes. Therefore, you can distinguish this also by action of heat, right? Option 3, calcium nitrate if you heat, what will happen? Calcium nitrate if you heat, you will get calcium oxide and reddish brown NO2 and oxygen. Whereas sodium nitrate if you heat, you will get sodium nitrite and oxygen. So this is your reddish brown fumes. You can also distinguish option 3. Therefore, 1, 2 and 3, all the 3 pairs can be distinguished by the options action of heat. Therefore, option B is correct. Kindly note it down. These reactions are there in your competitive manual. Kindly go through it. Beryllium, when react with sodium hydroxide, will give you B plus 2 NaOH will give you Na2BO2 plus H2. So 2 plus X minus 4 is equal to 0, X equal to plus 2. What is the name of this compound? Sodium berylate 2. Sodium berylate 2 is the name of this compound. Next slide. Which of the following statements is not correct? Standard reduction potentials of the alkaline earth metals becomes more negative on descending the group. Excellent. This is a great statement, because if you take lithium, standard reduction potential of alkaline earth metals becomes more negative on descending the group. Actually, children, this is a wrong statement. This is also one of the answers. I don't know why they have given option D, because lithium, see, all of you know that lithium is the best reducing agent. That means it can be easily oxidized. Why? Because it is having a large negative value. When you move from lithium to cesium, the negative value of SRP decreases. Therefore, this is also one of the options. Next, beryllium differs considerably from the rest of the alkaline earth metals. It is correct statement, true statement. Anhydrous salts of beryllium are covalent, whereas that of barium, calcium, strontium are ionic. Anhydrous salts of beryllium are covalent, whereas those of barium, strontium, ionic. True statement. Beryllium, magnesium burns in air to form oxide, whereas calcium, barium, strontium form peroxides. Most important fact is beryllium, magnesium, calcium. Beryllium, magnesium, calcium can form monoxides, whereas strontium, barium, radium can form peroxides. Yes, I'm sorry. I'm sorry for that. Yes, I did not see this alkaline earth metals. It is alkali metal. I thought it's alkali metals. Yes, this is also, yeah, false statement. I would like to thank a particular student. Vinita, you are very correct. You are very correct. I have not read the question properly. I'm sorry. Excellent. Excellent, Vinita. Hats off to you. Let us appreciate Vinita for the prediction. Yes, this is correct. Alkali metal lithium is the best reducing agent, and cesium is the least reducing agent. Udit Kumar, I am coming to your doubt. Higher the reducing agent, higher the higher the reducing agent, higher the negative value. We can determine the reducing agent easily. Yes, no, yes. Udit, you are also right, but the question is related to alkaline earth metals. It is not related to alkali metals. Therefore, the statement what you have told is true to alkali metals, not to alkaline earth metals. Okay, yeah. Kindly note it down. Next slide. Which of the following is found in biological fluids? Very simple. It's related to the biological question. It's a biological fluids. In biological fluids, you have sodium, potassium, magnesium, and calcium. These are all available in the neurons. All these available, or all these ions are available in the neurons in the brain. Therefore, they are available in the biological fluids. Also, in the cells, these cells are available, but not strontium or barium. Therefore, option C is correct. Next slide. Which of the following statements is not correct for alkali metals? Alkalic metals are the most electropositive. Correct statement. Alkali metal exists free in nature is completely wrong. They are highly reactive. Therefore, they exist as halides in the combined state. They cannot exist as a free state. These metals have largest size in the particular period of the periodic table. Absolutely correct. Because when you move from left to right in the periodic table, size decreases. Therefore, this is a true statement. This is also true statement. Option B is false statement. Next slide. Ionization potential of sodium would be numerically as same as the electron affinity of Na plus. What could be the reason for this? See, very simple. Na giving Na plus plus electron. This represents your ionization energy. Na plus electron giving Na minus. This is electron affinity. See, both values are equal but opposite. Equal but opposite. Numerically equal means the number is equal. They are not mentioning the signs. Sign is not mentioned. Therefore, option A is correct. Numerically, only the number. Sign they have not mentioned. No. Okay. Electronegativity we cannot discuss. Electron affinity of helium we cannot compare. Ionization potential of Mg also we cannot compare. So option A is correct. Doubt from students. Electron affinity of an atom is equivalent to energy produced consumed by adding an electron to it. Yes, that is correct. But these energies are equal and opposite. Udit, they have discussed here only the numerical value, not about the sign. Praneshwar, second statement is Na plus plus electron giving Na. Second statement is, what is the meaning of electron affinity? What is the meaning of electron affinity? Electron affinity is the amount of, yes, here there is a mistake from my end, I'm sorry. With respect to sodium, yes, Praneshwar, you are correct. Electron affinity of sodium means this should be the answer. Yes, correct. Please, children, please correct it. Praneshwar, hats off to you. Thank you for correcting me. Udit Kumar, ionization potential of an isolated atom is the energy required to release electron from it. Correct. That's correct. So energies are equal and opposite. That is what is the statement. Praneshwar, thank you for correcting me. Thank you very much for correcting me. Next. Elements of group 1 provide color flame to the Bunsen burner due to low ionization potential. Because flame to the Bunsen burner has a minimum energy by which it can liberate an electron. That is the reason alkali and alkaline earth metal shows the flame. D block metals doesn't show the flame test due to this fact. It's not due to softness or low melting point or presence of one electron in the outermost shell. So because of low ionization potential. Yes, Udit, you are correct. That can happen. And one more thing, color of the alkali metals in the Bunsen burner is due to the fact that when electrons gets excited, it comes to the ground state and it reflects a wavelength which is available in the visible region. Only if it is in the visible region, the color will happen from VIBGYOR wavelength. Otherwise, it cannot. That's also one of the very important statement what we have to discuss. Which one of the alkali metals can form normal oxide on heating in air? Lithium is the answer. Lithium is the only metal which can form lithium oxide in air. Potassium, rubidium can form superoxide, and sodium can form peroxide. Option C is correct answer. Which hydride is most stable? See, once again, the same story I'm coming to you. There cannot be a stable chemical bond between ant and an elephant. There cannot be a stable bond between ant and elephant, therefore it is unstable. That means lithium and hydrogen. See, this is both are belonging to second period, right? This is the first period, no doubt, but this is first and second period. So approximately the size will be almost the same, right? So lithium belongs to second period and hydrogen belongs to first period. Therefore, the overlap will be effective. Therefore, it is more stable, thermally stable, whereas cesium hydride is least stable. We can also say one more thing. Cesium hydride can supply hydrogen easily. What is that? Cesium hydrogen can supply hydrogen easily. Whereas lithium hydride cannot supply hydrogen easily because of stable. Therefore, the cesium hydride is a best reducing agent. Lithium hydride is the least reducing agent. This also we can say. It's a very important fact. Kindly note it down. Next slide. Which of the following represents the correct sequence of reducing order of the following elements? Yes, this is what I was telling. When you come from lithium to cesium, lithium has large negative standard reduction potential value. Therefore, it is the best reducing agent. Therefore, option A is correct. Next slide. Option D, lithium, sodium, potassium, rubidium, cesium. Yes, I'm sorry. Children, all of you are correct. Option D is the correct statement. Option D is the correct statement. I'm sorry I have picked the wrong answer. Danyata, Ganashri, you are correct. Option D is correct. Children, please tick the correct statement. Lithium to cesium, the option D will be correct. This answer is given wrong. I'm sorry. Option D is correct. Kindly note down the correct answer. Thank you very much, children, for correcting me. Okay, going to the next question. The products obtained on heating lithium nitrate will be lithium nitrate. When you heat, you will get lithium oxide, nitrogen dioxide, oxygen. Reddish brown gas is evolved. Therefore, option A is correct. Next, lithium nitrate on heating will give you X is Li2O plus NO2. Already we have seen in the previous question. Number 2, sodium nitrate on heating will give Y, that is sodium nitrite and oxygen. X is sodium nitrite. Therefore, option C is correct. Washing soda has a formula Na2CO3.10H2O. Straight question, children. Option B is correct. Next question. It's a very simple question. Calcium will have brick red. Then strontium will have crimson red. And barium will have apple green. Match the following. 1 and 3. Calcium is, which are the following not correctly matched. 1 and 3 is not correctly matched. 2 is correctly matched. Therefore, option A is correct. Next slide. Which are the following compounds that correct the order of increasing solubility? Calcium fluoride is least soluble compared to magnesium fluoride. Magnesium fluoride is highly soluble, and beryllium fluoride is very, very highly soluble. So calcium fluoride is least soluble, and beryllium fluoride is highly soluble, because remember one thing, when a compound is soluble, we can say that hydration energy should be greater than lattice energy, right? This is true for beryllium. Match the following. Once again, lithium can form monoxide, right? Next, cesium can form superoxide, sodium can form peroxide. So therefore, A and P correct, B and R correct, C and Q also correct. Option C is correct. Assertion reasoning. Compounds of beryllium is largely covalent. 1 second, there's a doubt from a child. Even potassium and rubidium can form superoxides. But Udit, going to the previous question if you want. It's a question is about lithium, sodium, and cesium. So compounds of beryllium largely covalent and get hydrolyzed easily. Reason, this is due to high ionization potential and small size of beryllium. Both are correct. Both are correct. So assertion is correct. Reason is correct. Reason is the correct explanation of assertion. Therefore, option A is correct. Next slide. Radium is the most abundant element of S block. This is not true. Radium is not abundant. False. S block elements are non-radioactive in nature. This is correct. So assertion is incorrect. Reason is correct. Option D is correct answer.